Hello Math 20-2 and welcome back to your 6th lesson in measurement. In today's lesson, we are going to compare linear scale factors and area. So see how linear scale factors affect area. So then linear scale factors eventually to area scale factors. So to start off, I'm going to help you with this table here, okay? So first of all, we have our original dimensions are 3 by 5. Our area of 3 by 5 is 15 because that's just length times width. And then we have the linear scale factor of 2 is applied. So that means both the length and the width are doubled in size. So my new dimensions are 6 by 10 and the area is 60. So the area scale factor is new area divided by old area, which will give me 60 over 15, which is the same as 4. So in this, we're going to pay close attention to this value and this value and see how they're different. Remember from the one before, when we did perimeter and linear scale factor, my scale factors were the same. The perimeter scale factor and the linear scale factor were the same, but we can already tell from this they're not always the same. Okay? So we're going to try and figure out exactly what they are. So take a look at the next one. We have 9 by 6. Okay? So 9 by 6 gives us an area of 54. Now, we want 1/3. This is a scale factor of 1/3 of 9 by 6. So 1/3 of the length, which is 1/3 of 9, is 3, and 1/3 of the width, which is 2, 1/3 of 6. I multiply these together, I'm going to get 6. So my new divided by old, we have 6 over 54. Now both of these can be divided by 6, which gives me 1 over 9. Okay? Let's take a look at my next one. 4 by 8. So 4 times 8 is 32. Now we want to find my new one. So I have to go 3/2 of the width. So 3/2 times 4 is going to be 3 times 4 is 12, divided by 2 is 6. And then we want 3/2 of 8. 8 divided by 2 is 4, times 3 is 12. 8 by 12. That gives me 72. Okay? So my new divided by old, we're going to get 72 all over 32. Now I look at this, both of these can be divided by 8. So 72 divided by 8 is 9. 32 divided by 8 is 4. Okay? There we go. Now, compare this to this, just like we compare this one here to that. Always keep in mind, look at that. Maybe you're starting to see the ratio or how they relate to each other. Now let's take a look at the next one. 3 times 12 is 36. And now we want 2/3 of this, so 2/3 times 3 is the same as 2, and 2/3 of 12 is going to give me 8, which gives me 16. Okay? So I look at this, this is going to give me 16 all over 36. Alright? Now, both of these can be divided by 4. So that's going to give me 4 over 9. Both can be divided by 4. So I simplify it down. Look how this relates to that. Okay? So I want you to think about that and why they are like that. Okay? So pause, write down, think why. What's a little secret here? How do we get the linear scale factor to the area scale factor? And why is there such a difference? And how do we get to that? Okay, so let's take a look now at question number 1. Maggie has scanned an 8 by 10 photograph on her computer. Okay, Maddie would like to increase the size by 44%. So that's 100% plus 44, which will end up giving me 144%. Okay, so now what is this in scale factor terms? This is the same as 1.44. Alright, so that's the area scale factor. Now, I want to know what is the linear scale factor. Well, we look at these here, we have to multiply something in twice, once to the width and once to the length. So this had to be multiplied by something, this had to be multiplied by something. And the scale factor must be the same thing. So in order to multiply by the same thing, we know both of them multiplied together is 144. We're going to have to square root 1.44. Square root that, and I'm going to get 1.2. So that is my linear scale factor. Because if I go 1.2 multiplied by 8 and then 1.2 multiplied by 10, then I multiply those together, I'm multiplying in 1.2 twice, which gives me 1.44, 1.2 times 1.2. Okay? Now let's take a look at the next one. Explain why these scales are different. Well, we just kind of explained that. Because the linear is multiplied in twice, 2 times, to both the base and height. Okay? Now, to both the base and the height. I don't need that bracket there. Alright? Now, whereas the area factor is multiplied in once. Therefore, we have to square root the area factor. Okay? Or we could go the other way. If we square the linear factor, we're going to get the area factor. Okay? So next it says determine the dimensions of the enlarged photo. So that's going to be 8 times 1.2 multiplied by, and we have 10 by 1.2. So 8 times 1.2 gives me 9.6, and then we have by 1 by 12. And these are in inches. Okay? My next part here says the enlarged photograph will be printed on digital print shop on a color printer. So we're going to assume that even when the printer prints the picture, the whites in there are colored too. Alright? So using the dimensions, let's do an enlargement. So we're going to use already these enlarged dimensions. So we have to go area is equal to 1.2 multiplied by 8, and then we have we want 10 multiplied by 1.2, both of my enlargements, which gives me 9.6 multiplied by 12, which ends up giving me 115.2 inches squared. Okay? Now let's take a look at the next one, my area. Well, if I'm using the area of this one, first of all, using the original area and area scale factor, we just go 8 multiplied by, what is that? 8 multiplied by 10. Sorry, I have to think of what we were doing. 8 multiplied by 10, which gives me 80. Right? But now, we want to multiply this by 1.44. And isn't that the same as multiplying 1.2 by 1.2? That is 1.44. So this is going to give me 115.2 inches squared after my enlargement. Okay? So now let's take a look at E. E wants us to do a reduction of 25%. Okay, so we're now doing a reduction. So that is 100%, subtract 25%, since it's reduction, we're losing 25, which will give me 75% of my original. Okay? So let's continue this now. So, and it says we want to know that this is going to be my area. So the area reduced by 25%. So that's 0.75. Determine the dimensions of the print to the nearest hundredth of an inch. So we want the dimensions of the print. Okay? So basically, this is my area. So we have 3 over 4, or 0.75, is my area factor. I'm putting area scale factor. Okay? Now to find my linear scale factor, I have to square root that, because we need to multiply each dimension by the same number, which eventually gives us this, right? So we want to square root both of that, okay? Square root all of this, okay? Or, all right? So, now let's take a look at this. So what are my dimensions? We have 0.75, the square root, multiplied by 8, and the other one is going to be the square root of 0.75 multiplied by 10. So that's going to give me 6.93 inches by, and this one's going to be 8.66 inches. So it's 6.93 by 8.66. And that is my new dimensions. Okay, that makes sense. It's a little bit smaller. Okay? So let's look at this next example. We have Marco, owner of Map It Inc., has produced a map of Canada with his employees. Now, it says the area of the province of Alberta is approximately this. Now, Marco's map, the area of Alberta is this. Now, notice how we're in square, so we're looking at area. And now the scale of the map, scales are always done in linear, can be written in the form 1 to x. Now, we want to figure out what x is to the nearest whole number. So we're going to start off here, okay? Now, I know we have 6. Let's take a look at my new. My new is always over old. So I'm going to go 264.74 divided by 661.850. This is all in square. This is centimeters squared, kilometers squared, is equal to, we want 1 centimeter squared over x, or I'm going to say y in this point, kilometers squared. Okay? So if I solve that, okay, rearrange for y, so then we get y is equal to, I'm going to solve this, so let's take a look. I'm going to go 661.850 divided by 264.74. And I hit enter, gives me 2,500. So y is equal to 2,500 kilometers squared. Now here's my problem. This is area, right? This one here is area. And this is now a ratio, not a rate. Okay? So this is my area. So we have 1 centimeter squared is the same as 2,500 kilometers squared. So I want to get rid of that. And how do I get this into linear? Because we want in linear, we have to square root both. Square root, square root. So I get 1 centimeter is the same as 50 kilometers. Okay? Now, next part here. Well, this is in kilometers, this is in centimeters. We want them to be the same. We want them both in centimeters. So there's 100,000 centimeters in a kilometer, because there's 1,000 meters in a kilometer. So that will give me 50,000 meters. And then I have to multiply it by another 100 to put meters into centimeters. So we end up getting 1, 2. Okay? So first, we did it 1,000. So 50,000, then another 100. So that is my ratio. Okay? Now, it says, on the same map, the area of the province of British Columbia is represented by this here. Okay, so that's in centimeters squared. So now it says determine the actual area of British Columbia. So let's go with my ratio. We want new all over old. Now, I'm going to use this here, this 2,500, because we're looking at squared. So I want centimeters squared, and it wants it in kilometers. So I'm going to use the kilometers squared and not anything else. Okay, so I'm going to put down here 2,500 kilometers squared. All right? Because that is my area ratio. Now that is equal to, now what is the area of British Columbia? We have 3 376.839. That's the new area because that's the one on the map. And we want to know what the old actual area is, so I'm going to leave that as x. And that's in kilometers squared. So I'm going to rearrange this. This will go up there. So I end up having to, we end up getting x kilometers squared is equal to 376.839 centimeters squared divided by 1 centimeter squared, because this will go on the bottom. Then we put that on top, so we're going to end up getting 2,500 kilometers squared. Okay? Do you get that? Now, just multiply that out. So these centimeters squared cancel off. I'm going to get 376.834 multiplied by 2500. Okay? I believe then... Oh, it's 839. So I'm close. So, and it wants to the nearest 100 kilometers, so that won't matter too much. But we're going to get 942,100 kilometers squared. 2,000. I'm going to say 100. Because this would just increase a little bit by that 0.4. That's actually supposed to be a 0.9. I thought it was a 4. I should really make my letters a bit better. So that's what we end up getting from our calculator. Okay? So that's everything. Hopefully you understood this. Good luck as I see you tomorrow and we tackle these questions together.